Hey guys, these are notes for 5.6 that are unique to exactly how this homework assignment is going to go. And then 5.7 has a different set of instructions. They're essentially the same thing. We are doing one main idea. In 5.7 they get a little bit more complicated, a few extra steps that we have to consider. But 5.6 is really just the basic, hey, we want to find the zeros of a polynomial. And so when we think about a polynomial, we're typically talking about these types of shapes, these bounces, if you will, these curves. And in 5.6, we're only going to do the cubic, the x cubed version, which would be something like this. And so we're expecting it to cross 3 times. In this assignment, we're going to find all 3 of them. They're going to be real numbers. Some of them will be whole numbers. We probably get some fractions in there, but we're not going to do any square roots in this assignment. We will have to do a little bit of that in 5.7. But in 5.6, we're going to say pretty tame to start out, okay? So the main idea is that if you have an x cubed, okay, the fundamental theorem of algebra says that there will be 3 solutions. We'll cover that a little bit more in 5.7, but I'm looking for 3 solutions. Now the good news is we do have technology to help us. You know, 100 years ago, this process was definitely very different, and it was something that we would have to do a lot of work by hand and try to puzzle our way through what are even our good options. You know, do I guess 10 and try it, or what do I do? What we do know is that if we do synthetic division, okay, and the remainder is 0, we've found a factor, and therefore we found a 0 of the function. And so if we can use synthetic division on the numbers, the question is really, who do we put up here as our bouncer? Okay, and there's going to be 2 types of problems that we work with today. First option, well, both of them are going to have the same initial circumstance or initial idea, but we'll talk about how we can proceed. So I'm just going to go to Desmos, and I'm going to go ahead and type in, or I've already got it typed in, we're going to graph one of these example problems. Okay, so we're going to look at this top one up here. X cubed plus, minus 3x squared minus 4x plus 12. Okay, if I were to graph it, I type that in the y equals of a TI-84 calculator or use Desmos, and I graph it, this is what I see. Okay, is this image here. And I'm looking for these places where it crosses the x-axis. There are 3 of them, 1, 2, 3, just like I should expect for an x cubed. But I need to know where they are. If it's obvious, it's obvious. And in this problem, it's obvious. It crosses at -2, it crosses at +2, and it crosses at +3. Do we have all 3 locations where it crosses the x-axis? The answer is yes. So if this was one of our homework problems, we would say that the zeros were -2, +2, +3. Circle our answer and be done. So when you do any of these problems, step 1 is to graph it in a graphing utility and see if there's any obvious solutions. If there are, you're golden. Now sometimes, and Desmos is very good at helping us out, it'll find the zeros for us. I don't want to get too carried away. You need to understand this other approach. And so bear with me, even though I'm going to use Desmos, on a graphing calculator it's not going to be as evident. Maybe that's what we'll do with this other one. I'm going to throw it in the graphing calculator and talk to you about how it would be a little bit different here. We're going to have 2x raised to the 3rd. This is my exponent key here, 3. Got to get out of the exponent. Plus 3x squared minus 11x minus 6. So this is a little bit more like what you'll see on a test. Oh, look at that. It crosses right at -3. This crossing seems a little bit suspect. It looks like it's between -1 and 0, but I can't be certain. And this one definitely looks like it crosses right on the 2. So it feels like I have solutions at -3 and at +2. Well, let's go back to OneNote and let's do some writing here. We saw from the graph that it seems to cross at -3, at positive, no, +3. Oh, I'm on the wrong one. negative 3, there we go, and at positive 2. Those looked like good solutions for us. So I like that x is negative 3 and that x is 2. That's only 2 answers. I'm supposed to have 3 of them, and I could see the third one. It just was in between 2 numbers. When that happens, we have 2 choices. Both of them are going to take us to synthetic division. So let's take the original problem. Remember, it was 2x cubed plus 3x squared minus 11x minus 6. Whoops. So I'm going to take those numbers, 2, 3, negative 11, negative 6. I'm going to change my pen. I know sometimes that light blue gets hard to see. I can use either the negative 3 or the positive 2 as my bouncer. So I'm going to go ahead and put the negative 3 in here. Why not? And there's my drop down. 2, negative 3 times 2 is negative 6. 3 plus negative 6 is negative 3. Negative 3 times negative 3 is 9. Negative 11 plus 9 is negative 2. And negative 3 times negative 2 is a positive 6, which gives me 0. That has to happen here, or we're not finding zeros. Literally, this is one of the reasons we call them zeros. In synthetic division, they produce a 0. So I have 2 choices at this point. Choice 1 is to take this, it's now 2x squared instead of x cubed, minus 3x minus 2. I can factor this or put it in the quadratic formula. In 5-6 you won't need the quadratic formula, but you could. But if not, it's a 2x and an x. Actually, you know what? I don't like doing it that way. 2 times 2 is 4. This becomes x squared minus 3x minus 4. I'm going to try to stay consistent with how I factor in this class. X and x. How do you split a 4 so it subtracts to make 3? It'd be 4 and 1. So I've got a 4, I've got a 1. The 4 is negative, so I would have to have 1 of each. To get a negative 3, I'd go minus 4 plus 1. And these 2 numbers have to be divided by 2. So in this problem, I have x minus 2 times x plus 1/2. I'm going to leave it like that to say that x equals positive 2, which we already knew, right? We knew that, but it also equals a negative 1/2. If I include with that the 3 that I just ran through synthetic division, I have all 3 solutions. But here's the deal. We had a second choice, right? What if we had just done more synthetic division, not even tried to factor it? What if we kept going and used our second value that we knew was correct? Well, the 2 goes down. 2 times 2 is 4. Negative 3 plus 4 is 1. Don't forget I got a box down here. 2 times 1 is 2. And I get 0 again. Well, if we remember that the first 2 was x cubed, then x squared, this would just be a regular x, and this would be a regular 1. So if you had 2x plus 1 equals 0, you'd minus 1, get 2x equals negative 1, and divide by 2. And there's the negative 1/2. Depending on whether you prefer to factor or not, those are your 2 approaches. Either way, in 5-6, 3 answers every time. You should be able to dig all 3 of them out. Sometimes it's just a graph and you're done. I think 11 through 14, they're just perfect graphs, or whatever that first part of the homework is. It's so obvious and straightforward. You just graph it and you're done. Then you start getting these fractions, and to get the fractions, you're going to need to use some synthetic division to either then be able to factor, or second level, if you're not going to factor, you could synthetic divide twice and come down to a single value. And this is always really easy to solve right here. If you look at the 2x plus 1, okay, right here, I keep switching pens, sorry. 2x plus 1 right there. You just switch the sign of the 1 to negative and divide by 2. Negative 1/2. You're done. All right, good luck. Hopefully that helps you get through 5-6. There'll be a separate video for 5-7 to kind of give you a little tweak on what we're doing there. But for the most part, it's the same process.